Hey everyone, my name is Suyash and welcome to my YouTube channel. This video is a high-level overview of plugins in Google ADK and how they act as a central governance layer to make your agentic system, to make your agent ecosystem production ready. Let's get started. In this video, we are talking about plugins in Google ADK. In simple words, plugins give you global control over how your agent system behaves, not just individual agents, but your entire agent system. So instead of stuffing logging, security, caching logic into every single agent, we plug that behavior into the runner once. Okay. So for example, if you have a support agent, a billing agent, and an escalation agent, we can enforce the same security rule across all the three agents without writing it three times. So let's start with the problem that plugins are trying to solve. As the number of agents multiply, cross-cutting concerns become chaotic. So as soon as you have more than one agent, the same repeated concerns start showing up everywhere, meaning logging, auth checks, caching, metrics, policy checks, etc. All of that gets duplicated fast for each of the agent. And once that logic is scattered across all the local agents, it becomes difficult to maintain, right? And it becomes difficult to trust. So for example, a refund agent might check approval limits correctly, but a second agent that can also trigger refunds might forget that rule entirely. So because we're duplicating this logic, we may end up missing some part of the logic somewhere in one of the local agents, right? So plugins solve that by moving these concerns into a single global layer. So essentially, we write once and govern everything. This is the mental model I want you to keep in mind. The agents sit below and the plugin layer sits above them at the runtime level. That means you can define one security rule, one logging layer, one caching policy, and apply it across the whole workflow of agents. For example, think about company-wide audit logging, where you want every model call and every tool call logged the same way, no matter which agent triggered it. So plugins act as a central governance layer. Now this sounds similar to callbacks, but it's actually different from callbacks as well. So let's make the distinction clear. So let's look at how callbacks are different from plugins. Callbacks are local and specific. They apply only to a specific agent, whereas plugins are global. They apply to all the agents, all the models, all the tool calls. So a callback is usually tied to a particular agent instance, but a plugin is configured once on the runner and then it applies across all the agents, all the tools, and all the model calls. And one important rule is that if a plugin intercepts a flow, the local callbacks don't get a chance to override that, meaning the plugins precede the callbacks. For example, a callback might redact output for one healthcare agent, but a plugin can enforce this redaction across every healthcare workflow that's running in that application. Now that we understand the difference in the scope, let's understand what a plugin can actually do. So just like we saw in the video of callbacks in our 7th tutorial, there are three ways a plugin participates in the execution. First, it can observe, meaning it just watches and logs while returning none. So here the data flows through untouched. The workflow proceeds without interruption. You're just trying to observe what's happening in the execution. Okay. Second is it can amend, meaning the data is dynamically reshaped, but the standard execution path continues. And the third is intervene, meaning it can short circuit the execution flow by returning a value. For example, a fraud monitoring plugin might log every transaction check, add a compliance note to the model prompt, and block a payout tool call if the user is not authorized. So in this way, we saw that the fraud monitoring plugin did everything. It observed, where it logged every transaction check. It amended, meaning it added a compliance note to the model prompt, and then it intervened or short-circuited the flow by blocking a payout tool call if the user was not authorized. So now, how do we actually build a plugin? Let's look at that next. The implementation pattern is pretty simple. We extend the base plugin class, we define the callback methods that we care about, and then we register the plugin on the runner. The plugin registration step is important because plugins live at the runner level and not inside a single agent. A team might build a simple security plugin in one file, and then it can enable it globally by adding just one line to the runner setup. So now let's see where plugins can be attached in the ADK execution cycle. This diagram shows a map of where the plugins can attach in the ADK execution flow. So there are 7 areas that you can apply the plugins into. First is the user message. Second is the start of the runner. Then the agent execution, then the model execution, the tool callbacks, the event callbacks, and the end of the runner. So as you can see, the plugins are not tied to just one moment in the flow or one point in the flow. They can participate from the very first user message all the way to the final teardown. So a real request might be inspected at the user message stage. It could be traced at the model stage. It could be guarded at the tool stage, and then it can be enriched again at the event stage before it reaches the client. Now let's walk through these hooks in order, starting right at the input boundary. The first place a plugin can act is right at the beginning. The on user message callback can inspect or replace the raw user input. Then there is before run callback, which lets you do runner level setup before any specific agent logic runs. So an example is a bank assistant could block abusive or suspicious input before it ever reaches the agent, or we can attach the user's risk tier at the very start of the run. So even before the execution begins, we can apply some transformations. Next, the request moves into the agent layer itself. At the agent level, plugins can wrap the agent execution with before agent callback and after agent callback. Now, if you've seen our callback tutorial, you should be familiar with these callbacks because we discussed these callbacks in that video. Now here the precedence rule still holds, meaning the plugins are more important than the individual callbacks. So if the plugin level callback returns something other than none, right, where it either amends or intervenes, then the local agent level callback, the agent level callback is skipped altogether. Next comes the engine room where the model calls and the tool calls happen. Now this is where the plugins get actually powerful. They can hook into model execution with before model callback and after model callback, and they can also hook into tool execution with before tool callback and after tool callback. Again, these callbacks were already discussed in the callbacks tutorial, so do check it out. Now, because the tool calls often touch sensitive systems, external systems, this is where security plugins become really useful. For example, if an agent tries to call a tool refund order for $500, a plugin can block it before the refund tool touches the payment systems. This is where the security and control becomes useful. And for some reason, if something goes wrong, then plugins can help there too, because there are special callbacks for errors on model and tool. So let's look at that now. So plugins can also intercept failures. If a model call or a tool call raises an exception, a plugin can catch that through the error callbacks. So there are error callbacks also, the on model error callback and the on tool error callback. So instead of letting the whole run or the execution crash, the plugin can return a fallback response and keep the system moving. For example, your agent talks to a shipping API. If the shipping API is down, a plugin can catch that failure and return a safe fallback message. instead of crashing the entire support workflow. Now, after the execution succeeds, there is still one more phase where plugins can act. Near the end of the lifecycle, plugins can shape the output and handle the final cleanup or teardown. The on event callback can intercept each event before it streams to the client, and after run callback is the final hook for teardown work like flushing the metrics or closing resources, connections, and so on. An important note is this final hook, this last hook cannot change the final answer, but it's just useful for global cleanup. For example, a plugin could attach trace IDs to every streamed event and then flush the usage metrics to an analytics system once the run is over. Now that we understand the life cycle and where plugins can help us, let's look at what Google ADK already gives us out of the box. So one good thing about Google ADK plugins is that we don't have to start from scratch. There are already some pre-built plugins, out of the box plugins that we can use on the get-go. So some of the built-in plugins are Reflect and Retry, where it intelligently tracks tool failures and it automatically handles retries. Second is context filtering, where it automatically filters and compresses the genai context to manage token limits. Then there is BigQuery analytics, and then there is saving files as artifacts. So you can go through the documentation and you can use these pre-built plugins from day one. Of course, you can always develop custom plugins based on your requirement, based on your use case, but most of these pre-built plugins are useful across multiple use cases. Great. That's all for today. This was a high-level overview of what plugins are, what we can do with them, how can we develop them, where all in the ADK execution can we attach plugins. In the next video, we will do a live demo on how plugins can be used to make our agent system production ready. So stay tuned for the next video. Thank you.